This related rate problem is about leaking water. Water is leaking out from an inverted conical tank at a rate of 10,000 cubic centimeters per minute. At the same time, that water is being pumped into the tank at a constant rate. The tank has a height of 6 meters and a diameter at the top is 4 meters. If the water level is rising at a rate of 20 centimeters per minute, they use different units, meter and centimeters. When the height of water is 2 meters, find the rate at which water is being pumped into the tank. Okay, first we draw a picture. In an inverted conical tank means it's a cone upside down. So let's first we draw a cone. So this is the top. And then we have, this is a cone. All right. And then the height is 6, always 6. All right. So this is the middle. And then we have diameter is 4. So the radius is 2. The radius is 2. And this is the top. And then the height of the cone is 6 meters. All right. Just like other geometry problem, they will give you a time. So at a specific time, they have a height and they have a radius. So if the water level is rising at a rate of 20 centimeters per minute when the height is 2. So when the height is 2, that means somewhere in the cone, like at this point, there is a radius and then there is a height. So we have the radius, we have a height. If the water level is rising at a rate of 20 centimeters per minute, so the h is the height, right? So h is the height, and then water is rising at 20 centimeters per minute. So that means the dh dt with respect to time is at 20 centimeters per minute. And then the water is rising when the water is 2 meters. So when h is 2 meters high, find the rate at which water is being pumped into the tank. All right, what is the volume of a cone? So the volume of a cone is V equals to 1/3 pi r square, which is the area of the circle, and then times height. Okay, so this one we have r, we have h, we have to put this in one variable. All right, so to put this in one variable, the first thing that I am thinking about immediately is we have to use a similar triangle. So that part I am going to do it in another color. So we have to use a similar triangle. So how do we use a similar triangle? We have a big triangle and a small triangle. So the big triangle is here. So this is the radius, and then this is the height. So we have a big triangle versus a small triangle. So for the big triangle, the radius is 2, the height is 6. So this is and then for the smaller triangle, this is r, and then this is h. So we have 2 divided by r equals to 6 divided by h, and then we try to put this in terms of r in terms of h. So first we cross multiply, so we have 2h equals to 6r, and then we have r equals to 2h divided by 6. All right, so that will be my r, and then that is equals to 1/3 h. So this is my r. I am going to plug in r right here. So I have one equation in one variable. So go back to my primary equation. We have v equals to 1/3 times pi, and then times 1/3h square times x. So this is in one variable. Let's clean up the numbers. So we have 1/3 square, right? So 1/3 square is 19. 19 times 1/3 is 1 divided by 27. And then we have pi h square times h is h to the third. And then I have to find the derivative using implicit differentiation. So differentiate both sides with respect to time. So we have dv dt equals to, we have to take care of the power, right? So we bring the 3 down. The 1 over 27 and the pi are constant, so we are not touching them. So that is 3h squared. And then using implicit, you have dh dt. And then when the height is 2 meters, the waters are pumping into the tank, right? The fresh waters are pumping into the tank, and inside the tank, some waters are leaking out. So when the height of the water is at 2 meters, so h is equals to 2 meters, that is how many centimeters? So 1 meter is equals to 100 centimeters. So 2 meters is equals to 200 centimeters. And that's what we have to plug in into h. So that is my h. The 200 is my h. How about my dh dt? What is my dh dt? My dh dt is the water level is rising at a rate of 20 centimeters, right? So go back to the problem. The water level is rising at a rate of 20 centimeters per minute. So that would be my dh dt. So my dh dt is equals to 20. So let's plug in. So the dv dt is equals to 1 divided by 27 times pi times, let's bring the 3 over here. Let's bring the 3 over here, and then h squared, so that will be a 200 squared, and then the dh dt is 20. So overall, what do we have? dv dt, so that is, we have squared the 200 and then times 20, so that is 800,000 divided by, and then the 3 and the 27, that becomes a 9 pi. So that is the rate of change of the volume of the tank with respect to time. And then this one, are we done? Is this the final answer? dv dt. Nope, not yet, because we have fresh water going into the tank, and then inside the tank we have water leaking out, right? So the dv dt at a specific time, here is how we analyze the dv dt at the specific time, is water going in, pumping in, minus water leaking out. So what about the water leaking out? The water leaking out is 100, right? So minus the water leaking out is 10,000 cubic centimeters per minute. So that is the 10,000. And then coming in, what is the coming in? Coming in is this one, right? So the coming in is you have to evaluate the 800,000 over 9 times pi. So that is around 289,252.68. If you evaluate that using your calculator, take that, subtract 10,000, then that will be your answer. All right, so that is the answer of this question. I see you all in the next one.